Welcome friends. In this video I'm gonna show you how to sketch a Bode plot for a given transfer function. Let us take one example, which is GSHS equal to 1000 divided by S into 10 plus 5S into 10 plus 0.1S. First of all, make sure that in this brackets you have here 1. In place of 10 you have 1. So you should have form like something like 1 plus, and this is S, and any whatever the value here, for example T1, or here also you should have 1 plus something, S something T2. Here should be 1, so we need to make 1 here. So we'll do that. 1000 as it is divided by S will bring out 10 as a constant, 1 is remaining inside, plus S by 2. Then from here also take 10 constant, 1 plus S by 100. So we have brought in that form. So whatever cancels out, cancel, 10 cancel. So this is our new transfer function. Not new, but in new form. This is our GSHS. Now, next step is put S is equal to J omega. The steps which I am showing you, follow straight away that steps. These are really easy steps to follow. And very less chance are there for mistakes. J omega, 1 plus J omega by 2, 1 plus J omega by 100. From terms like these 1 plus J omega by 2, 1 plus J omega by 100, the new term we get something called as corner frequency. We write it as omega C1. And since there are two terms like this, these are two terms, so we will get two corner frequencies which are equal to 1 divided by whatever the coefficient of J omega is, will be in denominator here 1 by 2, so 1 by 2 for 1 omega C2. Whatever the J omega's coefficient is here 1 by 100, write straight away. So we get here 2 radians per second. Here we get 100 radians per second. For sketching a Bode plot, we need to have certain values. To get that value, we will draw some tables. So I am making this table for, one is for factor, magnitude, and phase. I am following very standard procedure and it will be applicable in each type of problem. So follow simply this procedure. In magnitude column, I am not going to calculate exactly the magnitude, but I am going to calculate the slope of the magnitude plot. And similarly for here phase, we are going to calculate for in each individual factor. First factor which we get from this equation is 10, which we call it as K, gain we call it. Then second factor is 1 upon J omega. Then third factor is 1 upon 1 plus J omega by 2. And last factor is 1 upon 1 plus J omega by 100. These are the factors. Now, for this column to be filled, there are certain rules. Actually, there are so many rules. What I have done is to make the task easy. I have summed up all the rules and collected all the data. For different factors, there are different rules. The question which I have chosen to show you is real commonly asked, and for example here we have factor k is equal to 10, which is of type of gain. For gain, in magnitude column we have formula 20 log k. So simply write 20 log k. K is 10. So write 10, and the value comes is 20. And the unit for this is dB, 20 dB. And this will be simply a straight horizontal line on Bode plot without any slope. Then for coming to 1 by j omega, go in this table. We have poles at origin of same type. Here power is n, we have power here is 1. So what is written here is, for 1 upon j omega, straight line with 20 into n dB per second slope and passing through omega is equal to 1, 0 dB point. So minus 20 into n, here n is 1, which comes with minus 20 dB per decade. We'll see later on that what does this minus 20 dB per decade means while drawing a Bode plot. And the main point to be remember here is this line will pass through point omega is equal to 1, 0 dB point. This is a really important point, and really it affects this point. Then third factor is 1 upon 1 plus j omega by 2, which is of the type of this one. We don't have this type in our question, this type. So for that it is written that line slopes are 0 dB per decade for omega less than or equal to P1. 0 dB per decade for omega less than or equal to P1. P1, our P1 is 2. Similarly, minus 20 dB per decade when omega is greater than 2. Similarly, this is also the same type. So write same, minus 0 dB per decade when omega is less than or equal to, here it is 100. When omega is greater than 100. We'll come to know later on whether omega is less than or equal to 2 or greater than 2, similarly less than or equal to 100 or greater than 100. We'll come to know later on. Then for phase, for constant gain, phase angle is 0 for k greater than 0 and minus 180 degree for k less than 0. We have k greater than 0, so phase angle is simple 0 here. Then for 1 upon j omega, phase angle is minus 90 into n. Our n is 1, so phase angle is simply minus 90 degree in our case. Then for this type of phase angle is minus 10 inverse omega by P1. Minus 10 inverse omega by P1. Omega is not known now. P1 is known. It is 2. Minus 10 inverse omega by 100. From this phase column, we'll get one equation by summing up all this. And this equation will be useful while plotting phase angle plot. Sum up all these, minus 90, minus 10 inverse omega by 2, then minus 10 inverse omega by 100. This equation would be helpful while drawing phase angle plot. In our standard procedure, actually we have to draw 3 tables. One table is completed. Now we'll draw second table, which is again for factor. Then for resultant slope, what resultant slope individual factor would be having, in magnitude plot case. Then start point and end point of each factor in terms of omega. We'll see that. What are the terms? First term was k equal to 10. Second was 1 by j omega. So that was 1 upon 1 plus j omega by 2. Really easy task this is, like a game. Just fill the columns. Resultant slope for first one would be the same. It wasn't having any slope, just a straight horizontal line at 20 dB. It is not having any slope. For second one, we had a slope of minus 20 dB per decade at point passes through point omega is equal to 1 and 0 dB. Now here the task starts. Whatever the previous slope is, write the same, and we'll sum the individual factors slope, and the slope for this factor, as we have said, that it depends on omega. So we need to see starting and end point of each term. So since we got first column frequency from this term and second from this term, simply write here first column frequency, which is 2, and it ends at 100, and similarly this one starts at 100, and we don't know where is its end point, so simply write 100, and whatever the value of this starts, make this as a end point of this term, so write 2 here, and whatever assume any starting point and give it name here. Let us say we assume point 1 to be our starting point. For gain, there is we don't need to bother about this. Now, as we have stated earlier, that if for this term, if omega is greater than 2, then slope would be minus 20 dB per decade. Since omega is between 2 and 100, which means it is greater than 2, so slope would be minus 20, hence resultant slope would be minus 40 dB per decade. Write it, whatever the slope comes, write it here, plus, now for this term, what we had written, that if omega is greater than 100, then slope would be minus 20. Since omega is between 100 and infinity, which means omega is greater than 100, so write 20 dB per decade, which means minus 60 dB per decade. So our second table is ready. Now third table, which is really very easy, the most easiest. Now third table, which is for phase angle. Now equation comes into picture, which we had calculated, which was phi is equal to minus 90. In first table we calculated this equation. Now this equation will be really very useful. Make simply 2 columns. This table is the easiest for omega and for phi. Select any arbitrary values of omega of your choice. I am choosing 0.1, 1, 2, 10, 100, 1000, and put each value of omega in this equation and calculate phi for each. If you put 0.1, you get minus 92.9 degree. If you put 1, you get minus 117.13 degree. Continue putting in each value. You get minus 136.14, minus 174.4, then minus 223.8 degrees, minus 264.1 degree. We got each value in with negative sign. Now let us go on plotting on semi-log paper. So this is we have semi-log paper. First of all, this is our x-axis. Mark all the omega on x-axis. We will start from 0.1 radians per second, then 1, then 10, 100, 1000. Enough. These are the omega values in radians per second. These are the darker lines, which are parting all these x-axis. This much distance means 1 decade. Remember, 1 decade. This is another decade, another decade. Now, first we'll plot magnitude plot. First, this is my 0 dB. Then I'm taking scale of plus 20 dB, then plus 40 dB, plus 60. Enough. Then minus 20 dB, minus 40 dB, minus 60 dB. Now, this is our reference line. Before starting to plot Bode plot, what we'll do is, since we have got with us, these are the from second table, we have slope of minus 20 dB per decade, minus 40 dB per decade, minus 60 dB per decade. We'll create a reference of these slopes in here. These are not part of our Bode plot. This is just for our reference. Then, what does this mean, minus 20 dB per decade slope? This means in 1 decade, your slope falls from 20 dB to 0. So in 1 decade, slope is falling from 20 dB to 0. Similarly, for minus 40 dB per decade, slope falls from 40 dB to 0 in 1 decade. Similarly, for 60 dB per decade, minus 60 dB per decade. These aren't the part of our Bode plot, these are just for our reference. Now we start plotting. In second table, for gain we have written 20 dB horizontal straight line. What is the significance of this horizontal straight line? We aren't going to actually draw this 20 dB straight line. From second factor, we'll come to know significance of first point. What does it say? That slope is minus 20 dB per decade, and point passes through omega is equal to 1, 0 dB. Omega is equal to 1 is here, 0 dB here. Since our what first column says 20 dB, so just add 20 dB up. This point shifts to here. This is the work of gain. Now here we'll draw a line of minus 20 dB per decade parallel to minus 20 dB per decade. This is our minus 20 dB per decade line. Draw parallel line passing through this point. Since what we have written in second table, it starts at 0.1 and ends at 2. So we'll start at 0.1 is here and we'll extend it till 2. 2 is, here is 1. 2 is here, which is first corner frequency. Then for third term, it starts at 2 and ends at 100 radian per second, and slope is minus 40. So take line parallel to minus 40 dB per decade line. Starts at 2 and ends at 100. Then for last factor, slope is minus 60 dB per decade, starts at 100, ends at infinity. Take line parallel to this line. Starts at 100, ends at infinity. Enough. We aren't actually mean to going to infinity. This is enough. So here we are over with our magnetic plot. Now we'll draw angle phasing plot. This third table. Since our value is starting at minus 90 and ending at almost minus 260, minus 264 actually. All values are minus. So we'll take a suitable scale. I'm taking minus 90 degree, then I'm taking a 30 degree scale, minus 120, minus 150 degree, minus 180 degree, minus 210 degree, then minus 240 degree, minus 270 degree. Now at omega is equal to 1 we have minus 92.9, which is somewhere here. Then at omega is equal to 1 we have minus 1173 somewhere here. In omega is equal to 2 we have minus 136.14. Omega is equal to 2 is here, somewhere here. Then omega is equal to 10 we have minus 174 somewhere here. Omega is equal to 100 we have minus 223. Then for last one we have minus 264. In phase angle plot you don't need any scale, just join all these points with free hand. So here your Bode plot is ready, and you have got 10 marks at least. Thank you so much for watching.